Wow, what a beautiful day. Too bad I have to go work in an office doing monotonous and repetitive tasks, like sharpening knives to be sold on the black market. Whoa, look, a hole. Maybe I should go jump in it. Ah, I'm falling. Whoa, where am I? My head hurts. I fell a long ways. Oh no, look, an alien. What do I do? A gun. I win.
Who are you? I don't have much time to explain. I'm a friend though. Follow me. Let's go to my secret laboratory. Sorry about that. My name is Bobby.
My name's Alfred, like Alfredo sounds.
Cool. Let me tell you our situation. So we're stuck on a planet of super evil aliens, and the only way off the planet is with this super secret rocket ship I designed.
Wow, that's a lot to take in. What do I have to do?
Okay, the only way for you to operate the rocket ship is if you understand how rocket fuel works. Thankfully for you, I've made this super amazing rocket fuel presentation just so you can get all the basics and fly back to Earth right on time.
So you can teach me?
Yes, I'll teach you.
The general physics behind the spaceship is really fairly simple. Basically, the combustion has to create pressurized gas to flow through a small mouth in order to create immense amounts of thrust. The amount of thrust must overcome gravity and drag in order to propel the rocket upwards. There are two main types of fuel, solid fuel and liquid fuel. Solid fuel is generally used in the first stage of the launch, while liquid fuel is usually used in the second stage. Solid fuel can be easily stored at room temperature and is cheap to make, while liquid fuel is much more expensive to make and has to be stored at temperatures as low as -400 degrees Fahrenheit.
Since burning rocket fuel is a combustion reaction, rocket fuel is a mix of oxidizer and fuel. Oxidizer is what reacts with fuel in order to combust. On Earth, the atmosphere is filled with oxidizer in the form of oxygen, which is why fires burn. However, in space, there's really nothing. There's literally nothing, so the rocket fuel has to include an oxidizer in order for it to create thrust. An oxidizer accepts electrons from a substance. Remember, Leo goes Grr. The stronger the oxidizer, the more explosive and flammable the burn. Since a rocket engine needs to lift a pretty heavy rocket, the oxidizer has to be pretty strong in order to achieve sufficient thrust. An important term in rocket fuel when discussing different fuels is impulse, which is the amount of thrust per amount of fuel burned.
There are many solid oxidizers that are used as the bases of rocket fuel, such as ammonium nitrate, ammonium dinitramide, ammonium perchlorate, and potassium nitrate. The most common is ammonium nitrate for multiple reasons. Although it does not have the highest specific impulse of solid oxidizers, it is by far the cheapest due to its mass production as a fertilizer. Additionally, it reacts to form two non-toxic gases, steam and nitrous oxide, and it burns at only 200 degrees Fahrenheit. The first problem with ammonium nitrate as an oxidizer is that when it is sparked and heated, the reaction shown before is not the dominant one. Instead, the dominant endothermic reaction will use up all the energy, stopping the reaction. When there is a sufficient amount of heat, the ammonium nitrate decomposes into ammonium and nitric acid, which creates very little thrust. In order for the combustion reaction to be favored over the decomposition reaction, there must be a very large amount of heat to sustain the combustion. In order to solve this problem, aluminum is added to the ammonium nitrate. The aluminum burns at about 1400 degrees, which provides enough heat to the ammonium nitrate to to produce the steam and nitrous oxide gases necessary for thrust. The second problem is that the fuel takes a lot of heat to ignite. When a rocket takes off, there is no time to heat up the fuel to 1400 degrees, which is required for the aluminum to burn. By that point, the ammonium nitrate would be gone. It needs to be ignited by a single spark. By adding a very small amount of sulfur, about 1% of the total mass, the fuel could be ignited by a single spark. With all the proportions set and the elements held together by a strong polymer substance, the first stage is ready for takeoff.
The second stage of the rocket usually includes a liquid rocket engine. A liquid rocket engine has a higher impulse, that is, more thrust per fuel burnt than the solid fuel engine. However, this also means the strength of the thrust is weaker, but can last longer. The fuel of the liquid engine typically consists of liquid hydrogen, hydrazine, or kerosene. Oxygen, the oxidizer, is stored separately from the fuel. The reason the fuel for the liquid and propellant is hydrogen is because it is the lightest element, and in rocketry, less weight means less resources and money, which is the win for the scientists. Although hydrogen is light, it has the lowest density of all the elements, which basically means a lot of it can't be packed into a small space. This is why the hydrogen is liquidized in order to store more fuel in the rocket engine. The same reason applies to the oxygen, which is also liquidized. However, because these liquids are unstable, in the sense that they evaporate quickly, a rocket must be fueled just a few hours before its launch, unlike the solid rocket engine. The second stage is also a combustion reaction just like the solid propellant. However, in the liquid rocket engine, because the two fuels are separate, their combustion can be controlled more easily, which is essential for maneuvering in space. And that was my presentation on rocket fuel. Alfred, I hope you understand how rockets work now.
Thank you so much, Dr. Fabian. Now I'll be able to get home nice and safe.
No problem. Good luck on your journey back home.
Thank you. Time to get in the rocket. Alrighty, here we go. Punching in the codes, initiating launch sequence, and we're taking off in 3, 2, 1. I made it home from the alien planet. 4 days and 7 hours ago, I landed on an alien planet and fought some aliens and was taken in by Dr. Fabian. Now my life is not so boring. And that's the end.